Hey guys, welcome back to Code. Today we're doing another Brainstellar Quant puzzle. This one is called Daughter or Son. This is an easy problem. And just to explain the problem really quick for you guys, basically we've been given a person called Sheldon Cooper, Dr. Sheldon Cooper, and he has two children. So the sample space obviously for such a scenario becomes something like this. This is the sample space before we're given any additional probability. And so all the three problems, so basically we've given three sub-problems over here. Each of them are independent from the other. And all of them are based on conditional probability. And to be specific, on the fact that additional information changes the probability of an event occurring. And this happens because the additional information changes the sample space that we have been provided with. So, for example, if we're talking about problem number one, first of all, since initially we was considered this sample space over here, but once we've been told and the additional information that the younger one is a girl, we can deduce that it's either this case or this case. So this becomes our new sample space for this conditional probability. And among these, we've been asked the probability of this particular case where both of them are girls. And we also know that obviously all these four cases are equally likely. So the answer for the first problem becomes 1 by 2. Similarly, for the second case, we initially assumed this general sample space, but then we have been given additional information that at least one of them is a boy. So that means that it can't be this case, but it could have been all of these three cases. And now we've been asked the probability of two boys, which is this specific case. So this becomes 1 over 3. So this is the answer for, sorry, there should be a 2 over here. Yeah, so this is the answer for sub-problem number 2. So coming to problem number 3 now, in my opinion, it is quite ambiguous. So I'm just going to explain how the author of this problem on Brainstellar perceived this problem, and I think what I believe is the way he was thinking about it. So basically, since we've been given two kids and we've been given names to each of them, so Boba and Kiki, right? Now what happens is we've been given additional information that Boba is a girl, right? And nothing about Kiki. And now we've been asked the probability that we have two daughters, which is the last case, basically this one over here, right? But first of all, we need to understand what is the new sample space. So now a few would argue that since we've already said that Boba is a girl is established, so the probability for Kiki would be 1 by 2, since Kiki could be a boy or a girl. But what I believe is the way the author perceived this question is that since we didn't really define which child, either the younger or the elder child is Boba, which basically means to say that Boba could have been either of this child or that child, and saying that Boba is a girl. This just means that at least one of the two children are a girl. So it could have been this case, or this case. And among these three, we've been asked the probability of this case. So in that way, the answer becomes 1 by 3. And this is what I believe is how the solution is perceived. Basically, this information just means that we are guaranteed to have at least one girl among the two children. And now what we've been asked is the probability of two daughters, which comes out to be 1 by 3. So I hope you guys liked this solution and you guys were able to understand it. And thanks for watching.